So now I will discuss the frictions here. So basically there are two types of friction, internal friction and external friction. What is internal and external friction? What is internal friction? First of all, this is basically a liquid is example of internal friction that we discuss in liquid mechanics, right? When H2O, for example, we have three examples. This is H2O, and the second one is honey. It's right here, honey. Okay. For example, this is a water. It's split all over the surface. The water formed layer above its one layer. So between them, force exists, which is force of friction, and produce friction, and this is also known as viscosity. Same for the liquid friction is also known as viscosity. This is external internal friction, right? For example, honey is spread, it is scattered over the surface, so it forms layer over one layer. So the force of friction exists between these two layers, which is known as viscosity. So this is basically an internal friction. Now, what is external friction? External friction, as you can see here, this boy surface 1, this boy, okay, the two surfaces 1 and 2, which arises when two bodies come in contact with each other and try to move, or there is a relative motion between two. The external friction is also known as contact friction. You can see this is coming into contact with the surface, so it always exists between two surfaces when they come in contact with each other. So this is internal and external friction, right? Now there are basically three type of external frictions. In external friction, we have three types. So let me move it and let's discuss that. Let's discuss that. Three type of external frictions. First is statics. The second is limiting. And the third one is kinetic. Statics, limiting, and kinetics. What is statics? Okay. The static friction does not depend upon relative motion, It does not depend upon the relative motion, neither it is affected by the relative motion. Neither it is affected, okay, by relative motion, right? It's only depend upon the, it's only the, it only deals with tendency of relative motion. Okay, what is tendency of relative motion? Then we discuss it with the help of a diagram. Okay, so for a while, consider this is a box. This is a box. A 1 Newton force is applied here. 1 Newton force applied to move in a forward direction, and same. The 1 Newton friction force, static friction force, or acting in opposite direction, so that it remains in its state, right? So one thing that you have to remember here that static friction is variable in nature. So that point is well. The state of friction is variable in nature. It changes, variable in nature, due to which it has no formula. Due to which it has no formula, right? It's okay. How 1 Newton force applied here and 1 Newton force acting in opposite direction. For a while, consider now I have applied 2 Newton force. Same 2 Newton force is acting in opposite direction again. Now I applied a 3 Newton force. So the same 3 Newton force is acting in opposite direction as well. 3 Newton force. So it has a one, okay. It does not have any formula, but there is a equation here. Not equation, I could say that property or criteria it follows. It is limiting static friction. Static friction is greater than okay. This static friction is greater than 0. Static friction and less than uh, okay okay and less than maximum static friction, with later on known as limiting friction. Maximum static friction here, right? For example, now I have applied, okay, this is the equation that we have to follow. State of friction is greater than 0 but less than maximum state of friction later on. The maximum state of friction later on known as limited friction, right? For example, now I've applied a force of 5 Newton, and now this box displays from its position, which shows that now it exceed the maximum state of friction. So right, so here I can make one I can use this formula for writing this pattern. That is one greater than one state of friction. I can write this is basically a way of writing a state of friction. This is Fs, which is greater than 1 and less than 5 Newton, right? Okay, so this is basically a static friction which is variable in nature.